Okay, so in integrated 3, 4.7, they want us to, oh, for number 8, they want us to solve each equation, basically get x by itself, then identify extraneous solutions. So an extraneous solution, I don't really like how it's called an extraneous solution. So solution means a number, when I plug it in, it works. Okay. An extraneous solution, extraneous means extra, right? So extraneous solution means an extra solution. So I understand why they're calling it a solution, but I don't agree with it. That's like calling a dog a black cat. It's not a cat. It's not a cat. So we shouldn't be calling it a solution. But that's, Miss Johnson's opinion. I kind of get it, but it's a little bit on the confusing side. So it's asking us to solve this equation and then find if there's any numbers that come, I like say pop out as a solution, disguised as a solution. But when I plug it back into the original equation, it does not work. Okay, so the very first thing that I'm going to do is I am going to copy this equation right here and then do all my work. So the equation is x over 2 minus 1 over 3x equals to 6. So the very first thing that I see when I look at this equation, I'm like, oh, there's all these denominators. And I am not a huge, I mean, it's fine. I could work with them now. But when I was younger, I didn't really like working with fractions. So my method was always to get rid of, oh, I wrote the equation wrong, to get rid of my fractions. So I can do that because I'm in equations, and all I'd have to do is multiply every single term by the least common denominator. So I'm going to ask you, looking at my denominators, what would be my least common denominator? So take a second to just think. And you're like, it kind of looks like it's 6, but you got that x right there. Exactly. So then my least common denominator is just 6x. Okay. So I'm going to put 6x next to every single term, just like this. And you did your job if in the next line, that says 6x, I promise, in the next line, you have no denominators. You have 0 denominators, okay? You actually do, it's a 1, but there's no more like other denominators than 1. Okay, so when I multiply 6x times x and then divide it by 2, you should see that the 6 cancels with the 2, leaving a 3. So here's 3x squared. Okay, so far, so good because I don't have a denominator here other than 1. And then when I do this one, 6x divided by 3x, well, that's just 2. So then I get minus 2. So 6x is just left with 2. And then here, 6x divided by 6 is just x, right? Because it's 1. 6 divided by 6 is 1. So we say equals to x. So if you had to pick, I like this pink equation way better than the original because I can solve this. This is now a quadratic, right? Essentially, this equation is from integrated 3, but this equation is now from integrated 2. And I can do that. So I've made my problem a little more simple. So I think. Okay, so the next thing I'm going to do is whenever I have a quadratic, I want this side to equal 0. So I'm going to subtract x on both sides. So I get 3x squared minus x minus 2 equals to 0. Remember that x and x squared are not like terms, so I can't combine them, right? So now you have a couple of options on how to solve this. You can factor it, you can complete the square, you can use the quadratic formula, you can graph it. There's a bunch of different ways that you could do this. My preference is always to factor it, but as I look at this one, I don't think this one factors. Okay, I don't think this one factors. So let me prove it to you that it doesn't factor. So here's me trying to factor it. So I'm trying to think of two numbers that multiply to -6 but add to -1. Oh, it does factor. What am I talking about? I'm thinking of two numbers that multiply to get to -6 but add to get to -1. And so those two numbers are -3 and 2. So I was thinking of this. I was thinking of what are my factors of 6? And I thought 1 and 5, but that won't get me to a 1. And then I thought 3 of 2. And then I was like, oh, it does factor. So -3 times 2 gives me -6. negative 3 plus 2 gives me negative 1, right? So then I fill out my little box. And then I fill this in. So the first term goes in the first box. So this term goes right here. The last term goes here. Oh, yeah. Goes right here, right? So then I put negative 2, and then these two numbers here, negative 3 and 2, go here and here, except for now with x's. So if you're wondering where the heck did I get this from, it's this thing. I just broke it up differently. So 3x squared matches with 3x squared. Negative 2 matches with negative 2. And 2 and negative 3 get broken up here. But if you add those two, it comes up as a negative x. Okay, so this is just this thing rearranged. Where did this, oh, this negative 6. Good question. This negative 6, very good question. Sorry. Let me move that up a little bit. This negative 6 comes from 3 times negative 2. This is A times C. Here's your A times your C. Negative 6. Does that make sense? Yeah, if you skip this yeah. Now I get what you're saying. If you skip this step, then you will think it's not factorable. So it's always A times C. Yeah, if you skip that step, then that's probably where you messed up. Very good. Good job. Okay, so then you factor, which I'm really confident that you know how to do this. So what's the biggest thing I can take out of here? Let's put it in this color. Yeah, 3x. Very good. Right? So then 3x times what gives me 3x squared? And you're like, oh, that's x. Yeah, this is starting to feel familiar, right? And then 3x times what gives me negative 3x, so that's negative 1. And x times what gives me 2x, and you're like, oh, that's plus 2. And just check, 2 times negative 1 is negative 2. So again, if you forgot factoring, there's a ton of videos on me factoring quadratics. Just Google that. It's not the, I use what's called the area model, array model. Some people call this the X, the diamond method. So you can Google any of those terms and you can remind yourself how to factor. But yeah, that was the only thing. If you messed up on that part, that's the only little, tweak that you need to make. Very good. So then what I do is I take my two factors, 3x plus 2 and x minus 1, and I rewrite this now. Again, so all I'm doing over and over again is rewriting it into equivalent forms. So believe it or not, this is equivalent to this, which is now equivalent to this. This is kind of equivalent to this, but not exactly. And you'll see, I'll explain why. Okay. So then the next thing I'm going to do is I am going to solve each equation equal to 0 using the zero product property, which basically says set u equal to 0, set u equal to 0, and then solve. So 3x plus 2 equals to 0 and x minus 1 equals to 0. So therefore, x equals to negative 2/3 and x equals to 1. So the last thing that I would definitely do is check to make sure that that all of them are answers, they're legit. So all I'm going to do is I'm going to grab my Desmos calculator and then plug it into my original. Use the original equation. Don't plug it into anything else below that because it might, serve you wrong. Okay, so I'm going to plug this 1 in first because it's easier to plug in. So 1/2 minus 1 divided by 3. I'm hoping that's equal to 1/6. If you hit this little fraction button here, it is 1/6. And I'm like, yay. The next thing I'm going to do is I'm going to copy this and I'm going to plug in up here to my x, right? Because that's where x is, negative 2/3. So I'm going to go like this and I'm going to hit negative 2/3. And I want the negative 2/3 to stay together as a fraction because if you hit negative 2 divided by 3 divided by 2, Desmos doesn't know which one you should keep together. And sometimes it actually matters and sometimes it doesn't. So that's why I'm telling you. Okay, so do you see how I just literally copied and pasted this guy on top of this x right here? right? Do you see how I just did that? And so that's what that is. That's all I'm doing. But where did you go, Desmos? Where did you go? In my many tabs, I know. Okay. And then down here is minus 3x. So then I need to put a parentheses on here and put negative 2/3 again. And do you see how this is your x over 2 minus 1/3 x? And I still got this crazy looking fraction, which is now 1/6. Yay. So that means I'm right. So neither of these are extraneous solutions. Ms. Johnson, what does an extraneous solution, what happens in an extraneous solution? Well, you did this math and we're going to assume that you did it all right. But then when you come over here to check the answer, it doesn't give you a true statement. It doesn't say this equals to 1/6, 1/6 equal to 1/6. It'll say something else like 0 equals to 1/6, which is not true. So these are both solutions here. So I'm going to copy and paste this. I'm going to copy this, put it over here and say, yeah, these are both my solutions. I'm set and I checked my answer. Does that make sense? So the tricky part about rationals is that you could get an extraneous solution by accident if you don't check your answers. Okay. The last little way that I want to show you that you can check this is using, again, Desmos, except for this time, I'm actually going to plug in my equation of x. So x over 2 minus 1/3 x, and you get this crazy looking, this is called a rational function. If you kind of see, there's a weird slant asymptote here and a vertical asymptote here, it looks like, right? And so I want to say when that equals to 1/6. So I'm going to type another equation down here and I'm going to put 1 equals 1/6. And do you see how you have like these three here, like these intersection points? These are actually the answer. So the answer is in the x because we solved for x. So this is a fraction which it's negative 2/3, right? If you turn this into a fraction, it's negative 2/3. And the other one is 1, which is exactly what we got over here. Okay, so a couple of different ways for you to check your answers. I'm a huge fan of checking your answer because that means that I can know that I know that I know that I'm right. All right.